Please allow me to introduce myself. My name is Sergeant Yerosef. I'm the Vice President of 3D Technologies at CamLogic. Today we're going to be reviewing some of the ShapeGrabber technologies, specifically in a three-dimensional scanning arena, primarily focusing on automated inspection systems. Thank you all for attending. With me, joining me this morning will be David O'Connor, who is the application engineering manager at ShapeGrabber. He will be jumping in and reviewing some of the video feed for his automated system and showing us a process of the automated inspection. For questions, I don't know if you guys can see through the webinar process. There are areas where you can type in questions. We're also going to be sending out or showing our contact information, and we'll be happy to take any questions offline after this webinar is complete. Very quickly, I'd just like to review just a couple snapshots on CamLogic and who CamLogic is and what it is exactly that we do. CamLogic is a leading provider of some of the advanced technologies. We have a very high focus and close relationship with our customers and partners in some of the advanced 3D technology fields. We're located in Oxford, Michigan, and we were founded in approximately 1995. Primary focus has been the Siemens product line. We've been expanding into other technologies over the years. We do have a proven track record with a double-digit annual growth over these years. We consider ourselves specialists in the engineering and manufacturing industries in helping our customers and partners provide solutions and implement technologies into the engineering and manufacturing world. So if we take a look at the spectrum or the overlay of the technologies that CamLogic offers, primary, as I mentioned, primary focus is in the CAD world, and as you can tell, CAD, CAM, CAE, PLM, PDM is a starting point. That takes us into some of the three-dimensional printing and rapid prototyping technologies, as well as three-dimensional scanning, which we're going to be covering today. This kind of shows you a good mix of the technologies that we cover, that we specialize in, and it really allows us to stay in touch with our customers through the complete engineering and manufacturing cycle, from product design through rapid prototyping, and going into some manufacturing, scanning, and reverse engineering. To break that a little further, as a CAD/CAM solution, we are a solid reseller in the Siemens arena. Basically, gives you a good mix, a good breakdown of where we break that down, from CAD solutions, simulation solutions, computer-aided manufacturing, and some of the PLM and the product lifecycle management groups. This gives us a good understanding of what our customers are doing, and allows us to integrate some of the Siemens products and tools into their environment. With that, we kind of track into some of the three-dimensional rapid prototyping and three-dimensional printing, specifically for this bringing on this three-dimensional printer off of Z Corporation. This is a full line of 3D printing technologies that we carry in-house and provide this both on the sales and services end. Obviously, a great technology for some of the product design out there, covering several different industries, from mechanical design, healthcare, CAE, and others as well. And the main focus and the main reason that we're here today is basically looking at some of the three-dimensional scanning capabilities. We're a full provider of ShapeGrabber technologies, a fully automated integrated system for inspection and reverse engineering. Today's focus is going to be on the ShapeGrabber automated inspection focus, and we're going to be showing some of our software technologies as well. As Geomagic is our primary go-to-market solution on the processing side for both inspection and reverse engineering. With that, I'm going to turn it over to David O'Connor, who is with ShapeGrabber. He's going to walk us through a demonstration of his system, as well as a process, an automated inspection process with the Geomagic products. David, whenever you're ready, you can go ahead and take over.
Good morning. Can you hear me all right?
I can, yes.
All right, so what you're looking at here is the AI 310 inspection system. We've got a webcam feed here. What I've got is the sample part already placed on the scanner. Now this is just held in a simple vise. There's no fancy fixturing required at all here. And what I'm going to do on the right, you'll see the ShapeGrabber scanning software. I'm going to set up for scanning this part. So there's two things we wanted to demonstrate here. One is essentially starting from scratch. We've got a part that just came out of production. We want to check this part for any defects. And then we'll also look at how we can automatically inspect the second part. So to set up for the scanning process, what I'm going to do is simply tell the scanner where I want to start scanning by setting my little slider here at the bottom of the part. And then I will also tell the system where I want to stop scanning, again just by adjusting my little slider here to the top of the part. And then I'm going to go in and tell the system how many scans I want. So for this example, I'll do a total of 6 scans, rotating the part 60 degrees between each scan. So now I'm going to start the scanning process. And from here, the system takes over, and all the data acquisition will happen automatically. So you can see that laser line moving down to the bottom of the part. And now it's actually acquiring the scan. So what we're doing here, as this laser line is moving across the part, we're capturing tens of thousands of XYZ points per second. You'll see that first scan appear in this green window on the right. Then the rotary table repositions that part, rotating it that 60 degrees that I input. And now it's acquiring a second scan. And this second scan will automatically be added to the set in the proper coordinate system relative to that first scan. So you'll see as it scans around, it will keep adding scans until we have a total of 6 scans in the right coordinate system relative to each other. So just to show you what you're not seeing here, I've got a scan head. This is what's moving up and down in the system. And the laser is coming out of this portion of the scan head, and the imager detects that laser on the part. So depending on where that laser light falls on the imager, we're able to calculate exactly how far away that point is in space through triangulation. So once we're done acquiring the data here, we will switch over to the Geomagic Qualify inspection software, and we will use this data that we've captured live here to inspect this part. So in this example, it just takes just under 2 minutes to acquire the data. This ends up being approximately 500,000 data points. And that's all user defined, so if you have a more complex part, you can choose to acquire more data. You can choose to input more look angles when you're scanning the part and scan at a tighter resolution, depending on the amount of detail that you need. Okay, so the scanning is done now, and again in this green window we can see the data that we've captured. This is nice, clean, organized data. Very little post-processing is required to make use of this data. So now I'll switch over to the Geomagic Qualify inspection software. And the first thing I'll do is bring in a reference model. So in this case we're using the CAD model of the part. The CAD represents the perfect part. So ideally, we want our part to match this as exactly as possible. Now I'll read in the scans that we just acquired. So we can see this is a set of scans. And I'm going to run just a simple little processing step here that's going to take those 6 scans and combine it into one data set. Now while that's processing, it'll just take a few seconds. What I'll do is I'll put a second part on the system and we can start acquiring data on it. So if we switch back to the scanning end of things, I'll place a new part here. I'll make this my B set of scans and start scanning. Now because the data acquisition happens automatically here, I can multitask like this and switch back to the qualify inspection software. So we've got the data here and we've got the CAD model. So the first thing we want to do in our analysis step is put those in the same coordinate system. The software can do that for us automatically. I'll use this best fit function here and you'll see it'll automatically match the data that we acquired as closely as possible to the CAD model. And now that those two are overlaid on top of each other, I can compare the two directly. And here we will see a color map representing the different deviations between the real-life part and the reference CAD model. So the color scale that we set up here, everything that's within 10 thou shows up green. So we can see the majority of the part shows up in green. However, when we rotate the part around, we do see there's this orange and red area indicating a high region. And since that's a mating feature on the part, that is potentially an issue. So now we can go in and analyze this further. What I'll do is define a section through the part. And this gives us a 2D view of both the CAD model and the data that we acquired. So if I bring this data into the dimensioning mode, I can go in and I can look at that area of deviation that we saw, and I can measure between the reference object and the test object to find out exactly how far apart it is. So in this case, we can see there's 23 thou deviation between the two. While we're here, we can go in and make some other standard measurements on the part. For instance, we can measure the radius of this feature here. And you'll see for each dimension, the software will automatically give us the measured value, the nominal value, the deviation, and pass-fail status, depending on the tolerances here. So we can go in and make a few different measurements on this sample. And lastly, we can go and generate a report. So this report will capture all the information that we just analyzed. We'll see that color comparison from many different views, as well as the summary of the dimensions that we made. So if we quickly look through this result here, we will see some different views of that color comparison, where we can highlight the deviations that we're seeing, as well as the specific measurements we made, and a table summarizing all of those results. Now, the great thing is we've inspected one part, and we've essentially gone in and manually defined the measurements that we want. But now here I've gone and acquired the second data set. So this is my B set of scans. So now if we go back to the Geomagic software, we can replace our original test data with the new test data. And again, I'll run a processing step just to take the 6 scans and combine it into one polygon model. What this is doing is it's removing redundant data, which we may have gotten from different scans at different angles that went over the same region of the part. And as well, it's going to take the coordinates that we captured and connect the dots essentially to generate a polygon model, which will be easier to visualize. So this, because we're dealing with hundreds of thousands of points, it just takes a few seconds. And once we have that data, we can run the program that was generated when we manually measured this part. So while I was going through the steps to inspect that first sample, you'll see over on the left, there's a program here that's been recorded. So now that if I simply go in and run that program that was recorded, the software will repeat all the steps that I went through. So it's doing the best fit step. It will do the 3D color comparison step. It will make the same cross-section, make the same measurements, and it'll put that result into a new report. So very quickly, we've found a defect in a part, and at the same time, we've created a program to go and inspect the same features on new parts. So if this was a multi-cavity mold, for instance, we could automatically go in there and check all the parts that came out of all the cavities from that mold. So here's our new report from the new data set. Again, this one very similar to the other one with similar defects in the part. So that is the demonstration that we wanted to show you today, and we'll be happy to take some questions at the end. So I'll just pass it back to Surgeon, and he'll expand on some of the technology that I've touched on here.
David, can you just confirm that you can hear me okay?
Yes, I can.
All right, great. Thanks, Dave. Appreciate your effort there. So to kind of complete the loop here, it basically all does start with the point cloud. It's kind of the center of what we're trying to accomplish here. And this little bullseye will give us a good breakdown of the different technologies that integrate into scanning, and specifically for the automated inspection process. So once we have the data gathered, we can do quite a bit with it. Obviously, in this particular demonstration this morning is focused on the automated inspection side, being able to create some reports and support several divisions of the manufacturing and quality control process, from first article inspection, product inspection, supplier quality, and some in-depth analysis. A couple arenas that we haven't covered today, but we will in the future, primarily on the reverse engineering side, being able to gather this data and get it back into some sort of a CAD or a CAM system, or even a rapid prototyping system for downstream applications. So just to kind of review and what David went over today, it's truly a fully automated virtual three-dimensional inspection process that we've covered. Once the machine is set up with the automation, it's as simple as being able to drop a part in, hit the scan button, and acquire the data. The power behind the analysis is really within Geomagic Qualify. It walks you through a fully automated inspection routine where it takes the operator error out of the equation. So this will really show you the process of being able to bring in a CAD reference, as-built part, or wire scan, walk through an alignment, a three-dimensional comparison, an in-depth evaluation, and finally creating some sort of a report, whether it's 3D PDF or just a standard PDF report that can be shared through the organization or the customers. Again, I want to highlight the fact that this is fully automated and fully repeatable. That we can follow those steps, again without having the operator interfere with the process. Just to highlight on the reverse engineering end, with some of the products that the Geomagic does offer, obviously more on the mechanical modeling, design intent extraction from a specific scan. This shows a good process of a relatively good combination of free-flowing surfaces with some parametric surfaces, and being able to walk through creating the scan, converting that to polygons, classifying regions and segmenting regions, creating the surfaces, and sharing that with a specific CAD system that could be fully parametric. So it's some of the power of Geomagic Studio. Another example is just more than design intent on a free form object. Geomagic Studio is the leader in the industry for free form surfacing and NURB type surfacing. And again, this just kind of highlights that process. So point cloud to polygons, very free form part here that's it's very difficult to model in any CAD system. Studio does give you that capability. With the addition of CAD, you can add some details and send it off to a manufacturing process. And of course, to tie in the three-dimensional printing systems, if you don't need to go as far as a CAD model, some of the tools that are available are rapid prototyping tools. Geomagic Wrap is available. Obviously, Studio can be used for this as well. Being able to scan an object, convert it to polygon, with some excellent polygon editing tools, and cleaning up those polygons, creating a thickness, a shell, and then sending it over to one of the Z Corporation printers that could be printed out in a physical object. That brings us to the conclusion of this morning's webinar. I do thank you for your time, and we, as mentioned, we would love to take questions offline. I know we do have the capability of answering questions through a dialogue here, but please jot down contact information for both myself and David O'Connor. Feel free to get in touch with us either via email or feel free to contact us via phone. We'd be happy to answer any of your hardware or software questions at any time. Thanks again, and hopefully this was informative, and we look forward to hearing from you guys. Have a great day.